to all stations. Mark.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4.
Dateline, United Kingdom. Today on these British Isles, an undisclosed number of Thor missile units are being ready to supplement the present deterrent force. This is Weapons System 315A, a system designed around the Intermediate Range Ballistic Missile concept, the IRBM idea. The meaning of IRBM can be simply stated. Ballistic missile means the delivery of a nuclear warhead in a ballistic arc from one point on the Earth's surface to another point on the Earth's surface. Intermediate range means that Thor can achieve a spectrum of ranges from 300 to 1,500 miles. This concept has marked significance. Consider this globe of ours from the viewpoint of a polar projection, a top-of-the-world look. There are two main land masses, the complex of the two Americas and the Eurasian complex. Prior to the advent of strategic missiles, the Air Force already had in effect a three-pronged or three-dimensional strategy to operate in this world geography. We had long-range bombers of the B-52 type, intercontinental bombers, capable of flying from one complex to the other and returning. We had intermediate-range bombers of the B-47 type, which can fly from bases located on the fringes of the Eurasian complex to any point on that landmass. We also had fighter aircraft like the F-84 and F-100, capable of flying from Allied bases within Eurasia itself, their range tremendously extended through air-to-air refueling. When missiles arrived on the scene, they began to augment the striking force of this kind of air power. ICBMs like Atlas and Titan, the intercontinental missiles, add to our long-range potential. An IRBM like Thor adds to our middle-range deterrent program. And a missile like Matador, with a range of several hundred miles, blends with our fighter force. For the immediate future, at least, the idea of combining aircraft and missiles, mixing them, seems like the ideal solution to defense. But not too long ago, 3 short years in fact, we did not have this ideal concept. And so we flash back to Dateline, summer 1955, Washington, D.C.
In 1955, this is where we stood. We had fighter aircraft like the F-100, backed up by the Matador. We had begun the development of the ICBMs Atlas and Titan to supplement the B-52. But we did not have an IRBM program to complement the B-47. We had a chink in our armor. We needed, and our NATO allies needed, a reliable IRBM as soon as possible.
Dateline, November and December 1955, Los Angeles, California. At this time period, there was already in existence in California a unit of the Air Research and Development Command. It was known as the Western Development Division. Later, the name was changed to the Ballistic Missile Division, referred to simply as BMD.
BMD was organized for one purpose and one purpose only, to carry out a crash program on the development of the intercontinental ballistic missile.
It was a unique organization spawned out of the creative talents of some of the nation's leading scientific minds.
BMD would eliminate red tape, shorten command and communications time, leapfrog development, work concurrently on all phases of the problem.
When the need arose for an IRBM missile, BMD was already going full bore on the 2 previously assigned intercontinental missiles, Atlas and Titan.
It was only logical that BMD also take on the development of an intermediate-range missile, since it is generally the same kind of bird as an ICBM.
BMD was asked to get the IRBM program underway with utmost speed. As it turned out, it took 50 days, 30 days to submit plans, and 20 days to freeze design. This was the speed, the new look in Air Force research and development. This is how it was done. On the 28th of November, 1955, BMD was directed to proceed with the IRBM. On the same day, contractors were notified to prepare proposals. These contractors were being asked to build an airframe, assemble the primary missile systems, test the product, develop and fabricate ground handling equipment, and simultaneously create a manufacturing capacity to produce the number of completed missiles we needed in the time available. In short, these companies were handed a real headache. Those contractors who thought they could meet the stringent demands submitted their proposals. On December 23rd, the Douglas Aircraft Company was notified that it had been selected to assemble and test the Thor IRBM. On the 28th, Douglas signed the contract. During the remaining few days of 1955 and on into 56, the design of the Thor airframe was rushed to completion. On the 16th of January, the final configuration was frozen. The contractors for the other major components of the missile were already working for the Atlas program. General Electric would supply the nose cone for the new Thor. The AC spark plug division of General Motors, the guidance unit. And North American's Rocketdyne division, the power package. Thor was in business, backed by an all-star team of military, industry, and science. Dateline, April 1956, Douglas Aircraft Company. 3 months in the story of the creation of Thor have passed. The groundwork on which all future actions would be based was underway. In offices, in shops, in laboratories, men were poring over drawings and blueprints, meeting for chalk talks, designing models and mock-ups. Factory areas large as football fields were being cleared. The great potential of American industry was beginning to stir. Missile technology was working up ahead of steam. It is strange that in this day of rare elements, alloys, and plastics, basic layouts often start with man's oldest material, wood. Thor was first a creature of wood, a skeleton of pine in which engineers could investigate and experiment, fit and refit, check and recheck. But the missile itself was not the only item that had its beginning in wood. Scale models were made to check the feasibility of airlifting Thor in existing cargo aircraft. Perhaps designers are only boys at heart. The same serious, intense concentration is evident as they play with these toys. But a toy, if it's good enough, can give valuable insights into real problems of clearance, balance, weight distribution. The entire concept of the Thor weapon system from the start was that it must be air transportable. Dateline, July 1956, Edwards Air Force Missile Test Center. 6 months have passed. Out on the California desert, test stands to check out the performance of rocket engines were being readied. The fact that these stands exist at this time points up the overlapping nature of the Air Force's ballistic missile program. These stands had been built for the testing of Atlas engines. Since Thor would use one of the booster engines from Atlas, these stands could be used for both studies. During the summer of '56, the first in a long series of engine tests was run. The power that would push Thor 1,500 miles through space was in the making. Dateline, August 1956, Los Angeles, California. Thor was taking on shape and substance. Assembly line methods, reminiscent of aircraft production, were transforming Thor from raw concept to finished product. Giant presses conformed sheets of metal. Welding machines joined metal to form the characteristic cylindrical shape of a ballistic missile. Some 8 months from zero start, Thor was being produced. Produced in such a manner that future operational missiles could come off the same assembly line without major redesign of airframe, guidance unit, engine, or nose cone. Dateline, November 1956, Cape Canaveral, Florida. 11 months have elapsed. During these months, the Missile Test Center at the Cape has been ready to receive Thor for test flight. A launch pad is ready. A service tower is ready. A control blockhouse is ready. The range is ready. And in 11 months, the first Thor, Missile 101, arrives. More, the missile arrives in the way intended, by air. Out of the C-124, Thor, for the first time, rolls over the ground that will witness its trial by fire. And so, during the closing days of 1956, Thor follows the script and moves into dress rehearsal. Thor is erected into its service tower. This is like a child being raised by proud parents for his first tottering steps. You have done your best in bringing up your offspring. Now it's up to him. However, such thoughts carry only so far. A missile is not a child. It is a mechanical giant. For one thing, it has to be fed thousands of gallons of liquid oxygen, which is only a fluid at the unbelievably low temperature of minus 297 degrees Fahrenheit. At last, Thor is fed and primed and ready. Ready, however, not for a flight, but for a static, a held-down test of performance. And Thor does perform, but not to the standards demanded. And before Thor can be ready for a full flight test, the year ends. 1957. 1 year in the story of the development of Thor has passed. We begin the new year at Cape Canaveral. During 1957, 10 missiles were fired from the launch pads of the Atlantic Missile Range. The first was Missile 101, the same Thor given a static test in 1956. The elaborate countdown was started during the day and carried on into the night.
Lock stopping valve closed. Close LOX tank vent. Close spillover. Monitor LOX tank pressure.
40 seconds.
LOX purchase on. On. CG2 purchase on. Arm.
T-minus 30. Mark.
Start tanks. Pressurized. Burning your fuel tank. Start tanks. Burning your fuel vents.
Minus 20 seconds. Minus 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6.
Test number 1 ended in failure. During the succeeding 8 months, 3 more firings were attempted with missiles 102, 103, and 104. All 3 failed to achieve the desired amount of success, although missile 102 was erroneously destroyed due to a failure in range instrumentation. On September 20th, 1957, missile 105 was ready.
For your attention in the blockhouse, please. Attention in the blockhouse. This is T-minus 35 minutes in a hot run. We're at T-minus 35 minutes in a hot run. Close the blockhouse doors. Close the doors. We're counting. It's T-minus 35. Man your stations. No talking, please.
Again, the launch area was cleared. Instrumentation focused on the missile, and the countdown carried on to firing. Fired was a success. 1 year and 9 months from scratch, Thor came of age. During the remainder of 57, 5 more Thors were fired. The first of these was a failure in a spectacular way. Missiles tested were successful, and as confidence grew, each firing became more ambitious. One of these flights exceeded design range by 900 nautical miles. Ample cause for some real backslapping in the Thor blockhouse. While early missiles were merely stabilized on an approximate trajectory, now the missile's own guidance system was phased in to steer the missile precisely to target. At year's end, the score added up to 10 missiles fired, half of these very successfully. A very creditable showing for a missile barely off the drawing boards. But while flight testing was a real highlight, of equal importance in 1957 was the preliminary work being done in planning for an operational capability. One idea dominates thinking. A missile, no matter how good, is useless unless it can be handled easily and effectively by the military in the field. Step number one was to work in diagrams, almost an artist's concept of what an operational site would look like. This was the first visualization. Diagrams merged into scale models, models of launchers and trailers, fuel storage and transfer systems. In short, all of the complex features of ground handling a new tool of warfare. This was the second visualization. Scale models then came to life in full-size units. A real prototype launcher was constructed. Fuel storage tanks were fabricated. Trailers were equipped with checkout and control equipment, pressurization trailers, power trailers. All of these real units moved into a demonstration area and were set up to roughly conform to the planned field installation. And the key men of the project came out to look and observe. This was a place to inspect, but it was also a place to imagine and to evolve new ideas and generate improvements prior to final design freeze. And so 1957 came to a close with Thor pointing its nose to the sky in an operational environment. This was the backyard of a factory, but it was symbolic of events that could happen in the backyards of the world. Dateline, January 1958, Missile Test Center, Florida. A C-133 is at the Cape with the new launch equipment aboard. Shortly thereafter, it is being tested in preparation for a flight test. Dateline, January 1958, Sacramento, California. Concurrent with events in Florida, on test stands in California, other missiles were being captive tested to learn something additional on such factors as vibration, duration of thrust. Dateline, February 1958, Edwards Rocket Base. Other Thors on test stands. The simultaneous feedback of information is at work. Here at Edwards, data will be gathered on environmental factors affecting Thor. The missile in the field may have to withstand Arctic cold, tropic heat, driving rain, sleet, and snow. You cannot make Thor an all-weather missile by guessing. You must test and know. Dateline, May 1958, Santa Monica, California. By this time, operational type missiles are coming off the assembly line in a steady flow. The soundness of basic design and production line tooling are paying dividends. Not only missiles, but all of the support equipment associated with it are also in quantity production. Here is a missile shelter under test. This will be home for Thor, a protection against the weather. Here, Thor will rest on alert status in a horizontal position until the shelter is rolled back and the missile is raised to the vertical position for firing. Dateline, June 4th, Cape Canaveral. Thor number 115 is ready for firing from an operational type launcher. This time, no flight readiness firing. This time, Thor will be fired cold, as in the case of true operational use. And the flight is a success. Thor takes off as well from this simplified tactical launcher as it had from the more elaborate R&D test launcher. Dateline, June 1958, Tucson, Arizona. A new and vital facet has become a part of the program: training. Training is simple logic. Mastery of arms has been with us ever since man threw the first spear, fired the first crossbow. Here today, men from the United States Air Force and from England's RAF master the specialized techniques of handling and firing a ballistic device. The diploma testifies that they are now missilemen. More specifically, missilemen capable of carrying out a new idea in defense, the IRBM idea. Dateline, September 1958, somewhere over the Atlantic. The significance of this aircraft flying the Atlantic is that it carries in its cargo compartment the first Thor to be delivered to an overseas base. Thor rolls quietly through the English countryside. 2 years and 9 months from inception, an IRBM missile is in the hands of one of our NATO partners. 2 years and 9 months. Streamlined development for the ballistic missile age is a fact. 1958. Over 17 years since the Battle of Britain. Then the people looked to the Spitfires and Hurricanes. Today, a new protector guards their shores. Dateline, late summer 1958, Cape Canaveral Range. By this time period, the use of the Thor weapon system has assumed wider proportions. Thor has another missile stage fitted to its nose section and becomes Thor Able, a new type of re-entry test vehicle. This vehicle is capable of hurling a nose cone over the ICBM range of 5,500 nautical miles. In other words, Thor Able can, at full range and with realistic velocities, gather data to check whether an ICBM nose cone is correctly designed. Thor Able becomes a valuable test instrument. It allows ICBM data to be collected by a smaller type missile, thereby allowing more flight test time for an ICBM like Atlas. Another example of the integrated ballistic missile program. Dateline, the Moon, summer and fall, 1958. During this time period, Thor became one of the vital stages in the Air Force Space Probe project. For the space probes, 3-stage missiles were assembled. Thor was the main stage, the prime propulsive package. Of the 3 attempts, the second try made in October of '58 was the most successful. On this firing, all 3 stages functioned nearly perfectly. The terminal vehicle was launched on its 2.5 days journey to the moon. A slight deviation in control put the missile off course. The terminal vehicle traveled more than 71,000 miles toward the moon before returning to Earth. While attempt number 2 did not achieve all objectives, much virgin information was obtained. This was the first real look at the Earth's magnetic field and at temperatures and radiation levels from 70,000 miles up. This missile attained a higher speed and went a greater distance than any vehicle before it. Dateline, December 1958, Vandenberg Air Force Base. This new missile base on the coast of California is the site of another one of Thor's ambitious undertakings. The Discoverer satellites will be fired in polar orbits, which will be the first time the South Pole to North Pole path has been used by any of the man-made moons. Early in '59, the first of these satellites, a 1,300-pound unit, was successfully put into orbit. Yes, with the versatile Thor as one of the prime tools, man in '58 was pushing back the frontiers of space, doing this with a missile that did not even exist 3 short years before. 3 short years. Speed of development, being ready now, is the big story of Thor. If the need should arise, operational Thors can be uncovered, fueled, erected, and fired within 15 minutes. This is a mighty symbol of the determination of the free peoples of the world to guard that in which they believe. Let us pray that the sound of this new thunder may never be heard in anger. Let us instead enjoy the delicious silence of peace in that dateline called the hopeful future.